Look at board. So I have asked you to consider an object, and that object is moving along a straight line path, something like this. Initial velocity of this object is u meter per second. It travels with an acceleration of simple a meter per square seconds. After simple t seconds, the object's velocity is v meter per second. Right? The time taken for the motion is simple t seconds. The displacement is s meter. Draw this figure here. Right? So for the velocity time graph, I have given you a motion like this. Draw this figure. After that, I'll explain this again. Now, after that, I'll explain the relationship between this and the velocity time graph. Draw it. Draw it. Right. How do you represent this motion in a velocity time graph here? I think time is enough for you to draw it. Right? Listen here. If I draw the velocity axis and the time axis like this, time is measured by seconds. You must indicate the unit. Velocity is measured with velocity is measured by the unit meter per second. Right? Here you can identify two velocities. Initial velocity is u, final velocity is v. So let me mark the initial velocity here as u and the final velocity as v. So velocity increases from, this is the 0. Here this is 0, right? So velocity increases from u to v, u meter per second to v meter per second within simple t seconds. So let me take this time duration as simple t seconds. This time duration is simple t seconds. Within simple t seconds, velocity increases from u to v. Right? Now look at board. Right? How do you represent acceleration? Acceleration is represented by a straight line. Velocity increases from u to v within simple t seconds. Acceleration. This is constant acceleration. So this is the graph, but please wait a minute. This is the velocity time graph, but please wait a minute. Let me mark this point as A, this point as B. Actually, this is the 0 point. This point as C. This point as D. This is 90 degree. This is as E. Please draw the graph here. Please draw the graph. Mark the points like this: A, B, C, D, E. This is how we represent constant acceleration, and I'm going to prove that this velocity time graph is true. What am I going to prove now? I'm going to prove that this velocity time graph is true. It correctly represents this motion. That's what I'm going to do. Draw it. Draw the graph. Yeah. This straight line graph represents the constant acceleration. Right? Initial velocity is u, after t seconds velocity is v, but we should prove that this graph is true. Right? So next thing, I'll explain the graph and I'm going to prove that this graph gives us everything. And this is the correct velocity time graph for this motion. That's what we are going to prove. Draw a very big graph like this. It's not UE line, it is AE line. AE line is the graph, U is the initial velocity, V is the final velocity. AE is the graph, U is the initial velocity, V is the final velocity. So if you are confused, I can use some different colors for U and V. So U is initial velocity, V is final velocity. AE is the graph. All the other things are supporting letters A, B, C, D. Okay, now, and time taken for the motion is simple t seconds. Complete. Right. How do you find acceleration from a velocity time graph here? How do you find the acceleration from a velocity time graph? You should find the gradient. So please mark this angle as alpha. So I want to find the gradient. First of all, let me please tell me what is this height here? What this height?
U.
Yes, 0 and this is u. So this height is u. What is this height there? 0 u. Therefore, this is u. This is 0. This is v. Therefore, what is this height there? This height?
V, sir.
V. Very good. So if this is u, if this is v, then what should be this height?
V minus
U.
V minus u. Very good. Very good. V minus u. CD length is u, CE length is v, therefore DE length is v minus u. Complete the note there. Complete these things, mark all of them on the figure. Start there. Right. So we know that Lamai, please come back to the class. Right. So we know that acceleration is equal to half. Somebody unmute the mic and tell me from a velocity time graph, how do you obtain acceleration?
Tan alpha.
Tan alpha gradient. That is tan alpha. So A equals what is tan alpha here? Opposite side AA divided by adjacent side AB. Am I right here? Tan alpha is opposite side divided by adjacent side. So acceleration is A equals dE, that is V minus U. AD, what is AD length? Lamai? AD length.
T.
Simple
Length
T
of the
seconds.
AD side. You tell me dear.
T seconds.
Simple T, yes. T seconds, yes. AD is BC and AD equal. That is simple T. Simple T. Now let me take T to this side. A times T equals V minus U. A T minus U can be taken this side as plus U equals T. So what is this here? So this is our first linear motion equation. V equals Lamai. V equals
U plus 80.
Plus 80.
U plus 80. So this is the well-known result and this is 100% correct. If this is 100% correct, this should also be correct. Why? Because we use this relationship to obtain V equal U plus 80. We are so sure that V equal U plus 80 is correct relationship. Therefore, acceleration equals gradient is also a correct relationship. Got it? V equal U plus 80 is 100% sure it is correct. To obtain V equal U plus 80, we have used acceleration equals gradient. Therefore, acceleration equal gradient is also a correct relationship. That's how we prove. Therefore, velocity time graph, this graph correctly represents this motion. And if you get the gradient of a velocity time graph, that gradient is equal to acceleration. That's how we prove this. That's how we prove it. Write it there. Write it. Write them all. Right. I want to prove one more relationship. Lamai, how do you find the displacement from a velocity time graph? How do you find displacement?
Area under the graph.
Area under the graph, yes, very good. So displacement equals area under the graph. Now somebody please tell me which one is the graph. Don't write this, please don't write this. Which is graph here? Y-axis, x-axis, or AE line? Which is graph?
Y-axis, x-axis.
No.
AE line.
Y-axis and x-axis, they just support. Graph is the AE line. So what is the first point you should remember that? Graph is the AE line. That's why I have used a different color. So what is graph here? Everybody?
AE line.
High end. What is the graph?
AE line, sir.
AE line.
And the other opposite is student thinks that area under the graph means area of this triangle. Again, it is wrong because I have seen a lot of times students think area under the graph means only this area. No, it is wrong. That is wrong. Area under the graph means you should take area under the graph means you should take it up to the time axis. You should take it up to the time axis like this. Everything is, this entire area is the area under the graph. Clear? Area under the graph means start from the A line, go until you meet the timeline. So area under the graph means you can identify two objects now, two figures actually. A, D, E triangle. A, D, E triangle and A, B, C, D rectangle. So area under the graph means the summation of area of A, B, E triangle plus area of A, B, C, D rectangle. So area of a triangle, somebody unmute the mic and tell me the equation that we used to find area of a triangle. Don't write. Somebody unmute the mic and tell me the equation that we used to find area of a triangle.
Half into base into height.
Half into base into perpendicular height. Very good. Area of a triangle is half into base AD. Half into base AD into perpendicular height DE plus area of a rectangle is length into it. Length is BC. Length is BC, width is AD. Right. Now, simplify this. Put the values that you know. Okay, I'll give you one more support. Half into no. I don't give you support. Try to simplify and try to prove that displacement equals ut plus half AD square. We know that S equals ut plus half AD square. That's the equation we use to displacement. So I have said that displacement is equal to the area under the velocity time graph. I have obtained up to this. Simplify and prove that this is equal to ut plus half AD square. Give a try, take a photo and send to my WhatsApp. Right here. I think we were disconnected, but I think we got the connection back. Like we were disconnected, but we got the connection back. Can you see the board clearly, Lamai? Lamai, can you see the board clearly?
Yes, sir.
Yes, sir. Yes, sir.
Right. Did you prove the equation? Did you prove the relationship?
Yes, sir.
If you have proved it, please take the photo and send to my WhatsApp here. If you have obtained it, please send a message to WhatsApp. Right, look at board here. So half into AD, that is T, AD length is T, into DE. AD is T, DE is B minus U. D, this is point D. Can you see the point D clearly? This is D, this is E. DE length is V minus U. DE length is V minus U. Plus BC. BC is T. AB, ABOBA. This is U. This height is U. ABOBE. Whether it is AB or BA, that is U. And now look at board here. Half into T into V minus U. I can write U easily. And T times U is UT. T times U is UT. But what is V here? We have obtained an expression for V. What is V? Lamai? Lamai, what is V?
U plus 80.
V is U plus 80. So in the place of U, I can write, in the place of V, I can write U plus 80. U plus 80. So then what will happen this year? This U and this U plus U minus U.
Yeah.
So what will happen there?
Cancelled out.
Cancel out.
I have taken so long time to say it here. This is plus U, this is minus U, U minus U, U and U cancelled out. The only term is 80. 80 is the only term. Right, so then you get that half into T into, here you have only 80, here you have UT. So this is half, what is T into T? Lamai, T times T, A, T times T,
Squared.
T multiplied by T, what is it?
T squared, sir.
T square. T multiplied with, answer quickly, T square plus EUT. So what is this here? Displacement is S. S equals half AD square plus UT. Do we write it like that or in other way? So what is this actually? Half AD square plus UT. Normally we write this equation as S equals UT plus half AD square. Therefore, this graph is correct. It correctly represents the motion, and area under velocity time graph is equal to the displacement, because by using that relationship, we have obtained a well-known 100% correct equation. As this equation is correct, this relation should also be correct. As S equal UT plus half AD square is correct, this should also be correct because we have obtained the equation from this relationship. Therefore, please remember that area under a displacement velocity time graph is equal to displacement. Complete everything here? And please raise your hand up if you got this relationship earlier than me. gradient of a velocity time graph is equal to the acceleration, and area under a displacement time graph is equal to displacement, right? So now we should try for a question. Let me show you a question which is given in my tute. If you do not have the tube, please don't worry, because I show you the question and I'll send you the image of photo of the questions to the WhatsApp groups. So if you do not have a printed tube, please do not worry about it. Can you all see the question properly, Lamai?
Yes, sir.
Right. So this is our 600 questions tube. This is the graph section. I'm going to discuss question number 96, which is given in page number 20. Page number 20. So if you do not have the tube, do not worry. Just after the class, I'll send you the question to the WhatsApp groups. Right. So let's try this question. Can somebody unmute the mic and read the question? Question number 96. Somebody unmute the mic and read.
A car travels at a constant velocity of 20 meters per second in the first 200 seconds and then accelerates during next 20 seconds till it attains a velocity of 30 meters per second. It maintains this velocity during the next 200 seconds and comes to rest within 30 seconds by applying brakes. First one, draw a displacement time graph and a velocity time graph for the above motion. Second question, find the acceleration when the velocity increases from 20 meters per second to 30 meters per second. Third question, what is the total distance traveled by the motor car? Fourth one, calculate the average speed of
Is it clear for all there? Let me read the question. A car travels at a constant velocity. Let me read the question for you. A car travels at a constant velocity of 20 meters per second for first 200 seconds. So during the first 200 seconds, the velocity of the car is constant, and that is 20 meters per second. And then accelerates during the next 20 seconds till it attains a velocity of 30 meters per second. So after the 200 seconds, during another 20 seconds, it accelerates and it increases the velocity from 20 to 30. After that, it maintains this velocity during the next 200 seconds and comes to rest within 30 seconds by applying brakes. Draw a displacement time graph and velocity time graph for the above motion. Find the acceleration when the velocity increases from 20 to 30. What is the total distance traveled by the car, traveled by the motor car? Calculate the average speed of the whole journey. Right. So first of all, let me draw the graph here. Let me draw the velocity time graph and let's do the calculations. At the end, we can draw the displacement time graph. Right. Let me give a try. Right. Can you see the whiteboard here? Can you see my whiteboard clearly?
Yes, sir.
Right. If you want any more time to write any of these things, please take a screenshot. I'm going to erase all the things. As I'm going to erase everything, if you want, you may take a screenshot. Right. Look at board. Right. Look at board here. What kind of motion is this here? During the first few seconds, it has a acceleration and constant velocity and so on. How many sections are there actually? How many sections are there? The object starts to move with a constant velocity. The object travels with a constant velocity of 20 meters per second. That's what's said in the question. During the, I'm talking about 600 questions due, question number 96. So you write it. So you write the heading as 600 questions due, question number 96. Right. So during the first 200 seconds, it travels with a constant velocity of 20. Then during a within 20 seconds, within a period of T2 period of 20 seconds, it increases the velocity from 20 to 30. Then it maintains this velocity for a period of 200 seconds. It maintains this velocity for a period of 200 seconds, constant velocity. And during the next 20 seconds, during the next 20 or 30 seconds, I don't remember it. Finally,
30 seconds.
30 seconds. Eh? Yes, thank you, Dave. During the final 30 seconds, so 30 seconds means we are here. During the final 30 seconds, it decelerates and comes to rest. First of all, draw this motion. First of all, draw this motion. This is the motion described in the question. And let me take this points as A, B, C, D, E. T2 is not T2. T1, T2, T3, T4. T4 is 30 seconds. So let me take the displacements as S1, S2, S3, S4. Complete them all there.